All right, so today for college algebra, we have the tangent sum and different identities. So it's along the same lines that we did yesterday with sine and cosine, but tangent we're going to do on its own because tangent is much more time-consuming and long. Okay, so in today's notes, we have 3 questions. That's it. But we only have 3 questions because, well, they can take a little time. All right, now the tangent sum and difference identities formula is not on this sheet, but I'm going to write it down on the sheet. You can find it if you'd like in the formula sheet that we posted on March 30th. It's the second semester formula sheet. Okay, so here is the tangent sum and difference formula. So it is tangent x plus or minus y is equal to tangent x plus or minus tangent y divided by 1 minus or plus tangent x times tangent y. Okay, now what do these mean? Because this can be kind of confusing. All right, the way this works is the formula part that you use, since it's plus or minus, is dependent on which one you use in the beginning. That doesn't really make a ton of sense, but here we go. So if you're using tangent plus, you're adding the 2 values together, you use the top signs here. You use plus and you use minus on the bottom. If you're subtracting the 2 terms, you're subtracting the 2 terms, you're going to use the bottom minus and then plus. Okay, so it's dependent on whether you add or subtract the tangent as to which sign you use. Otherwise, the formula is the same. It's just you got different positive or negative signs inside of it. Okay. All right, with that being said, let's get started with the notes. Okay, so the notes themselves, it's the same kind of idea as you did yesterday. We're trying to find 2 values that add up to be 7 over 12 that can both be reduced. Okay. All right, again, as a note from yesterday, people a lot of times will pick the wrong values. People do, well, 6 plus 1. Well, that's awesome. 6 over 12 can be reduced, but 1 over 12 cannot be reduced, so that wouldn't actually work. All right, 5 and 2. All right, 2 works, but 5 does not. So you got to find a numerator that can be reduced with the denominator. So for this case, what we're going to do 3 pi over 12 plus 4 pi over 12. Okay, that gives you 7, and they can both be reduced using 12. We'll end up with pi over 4 plus pi over 3. All right, so now we can put this into our formula. All right, so here we go. So it's going to be the tangent of pi over 4. Now, because we're doing adding, we're going to do the red signs there. So it's going to be plus tangent of pi over 3 divided by 1. Now, because we're doing the red ones, it's going to be minus tangent of pi over 4 times tangent of pi over 3. So this is the start of our formula. Okay, so next what we're going to do is figure out what the tangent of pi over 4 is and the tangent of pi over 3 is. Okay, so we're going to do that. Let's see, do that down here. So for pi over 4, if you go to your unit circle, you're doing y divided by x. Pi over 4 is nice because it's root 2 over 2 divided by 2 over 2. So I'm going to write that down. So tangent of pi over 4 is equal to root 2 divided by 2 divided by root 2 over 2. Since you're dividing something by itself, that's going to equal 1. So that's nice. Okay, the other one, you have tangent of pi over 3. All right, so pi over 3 is going to be, the y value is root 3 over 2, and the x value is 1/2. All right, so to figure this out, we have to multiply by the reciprocal of the denominator, of the bottom fraction. So 1 over 2 becomes 2 over 1. You're going to multiply that to the top as well. Okay, the whole bottom fraction gets canceled out, and then you have 2 and 2 get canceled out there. So you're left with the square root of 3. And that's it. Okay, so now what we're going to do is we're going to put these values, the 1 and the root 3, in for tangent of pi over 4 and tangent of pi over 3. So tangent of pi over 4 is 1 plus root 3 divided by 1 minus 1 times root 3. Okay, now luckily this is the easier version of tangent because we're not dealing with fractions of tangent. If you had the tangent of pi over 6, you'd be dealing with a different number, which would be a fraction, which would cause some more problems. And I will try and make sure I get into one of those next, which I'm pretty sure I will. Okay, and the next problem. All right, from here, what we're going to do is we're going to simplify the top and the bottom. All right, becomes 1 plus root 3. And the bottom is going to be 1 minus root 3. All right, now, people are going to want to say, oh, that's awesome, I can just cancel this stuff out. But the problem is they're not the same. If 1 plus root 3 was divided by 1 plus root 3, you could cancel the whole thing out. But because 1 is a minus sign, that causes some problems. Okay, now in math, you're not supposed to have square roots on the bottom of your fractions, so what we're going to do is we're going to multiply by what's called the conjugate. I'm going to write that down. Multiply by conjugate. All right, the conjugate, here we'll make the arrow a little bit better. The conjugate is the denominator with a different sign in between the numbers. You're going to multiply that on the bottom and the top. This is not because the numerator is what it is. It is the fact that the denominator is 1 minus root 3, so we're going to multiply by 1 plus root 3. All right, what this conjugate is designed to do is get rid of square roots on the bottom of your fractions. Okay, so now what we're going to do is we're going to multiply it out using distributive property. So we have 1 times 1 is 1. I'll write these in a different color. We'll do orange. 1 times 1 is 1. 1 times root 3 is positive root 3. I don't like that. We're going to do root 3 times 1 and root 3 times root 3. Okay, I'm going to change back colors. Okay, so 1 times 1 is 1. 1 times root 3 is root 3. Root 3 times 1 is going to be root 3 again. And then root 3 times root 3 is the square root of 9, and the square root of 9 is just 3. On the bottom, we're going to do the same kind of idea. 1 times 1 is 1. 1 times root 3 is positive root 3. The negative root 3 times 1 is negative root 3. And negative 3 times positive root 3 is going to be negative root 9, and the square root of 9 is 3. It's going to be minus 3. All right, now the conjugate is supposed to get rid of square roots, and there we have a positive square root of 3 and a negative square root of 3, so those will cancel out. And on the top, we have 1 plus 3 is 4. We have 2 root 3's, which means we're going to have 2 root 3. And on the bottom, we're going to have 1 minus 3, which is going to give you negative 2. But wait, there's more. Okay, you'll notice that the numbers we have on the outside of the square roots are all even numbers. Because they're all even numbers and they can all be reduced, you have to reduce them. If they're not all numbers that can be reduced, and it can be all odd numbers too, that doesn't really make a difference. It's just that, are they reducible? In this case, because you have 4, 2, and 2, they're all reducible, so you're going to reduce it. You're going to also get rid of that negative sign on the bottom. So you're going to do 4 divided by negative 2 is negative 2. All right, minus 1. Minus 1, but we don't need to write the 1, and the square root of 3 is left over. So you have 4 over negative 2 and 2 over negative 2. Those can all be reduced, and you get this as your final answer. Okay, there's a lot of work involved in these problems, which is why we're only doing 3 of them today. Okay, on the test, when we get to the end of the test, there will only be one tangent question. That'll be it. Okay, because they can be long. Okay. All right, let's try the second one. So we have tangent of 5 pi over 12. Again, we're trying to find out 2 numbers that can be combined to give you 5 over 12 and can be reduced. So we're going to use 3 pi over 12 plus 2 pi over 12. Okay, they can both be reduced, and they both add up to 5. So this is going to give you pi over 4 plus pi over 6. All right, so we're going to write down the formula. Okay, so it's going to be the same as kind of before. You have tangent of pi over 4 plus the tangent pi over 6. Again, because we're doing plus, then if you go back up to the top where I wrote the equation or the formula, we're going to use the red values. All right. Again, this is on your semester 2 formula sheet. All right. On the bottom, we're going to get 1 minus tangent of pi over 4 times tangent of pi over 6. Okay. Now we're going to find the tangents of these things. Tangent of pi over 4, we saw this in the last problem, is root 2 over 2 divided by root 2 over 2, and that equals 1. The tangent of pi over 6 is going to be 1/2 divided by the square root of 3 over 2. Okay, now again, because you have a complex fraction, you're going to multiply by the reciprocal of the denominator's fraction. So it's you're going to flip the second fraction upside down. All the stuff in the bottom fraction will get canceled out. The 2's get canceled out, and you multiply straight across. You have 1 over the square root of 3. Unfortunately, you can't leave square roots in the bottom of your fractions, so you have to multiply by the square root of 3 to the top, which gives you square root of 3 over 3. And that's what the tangent of pi over 6 is. Now, since we're only dealing with, generally, 3 values for tangent, okay, it's either going to be a pi over 6, a pi over 4, or a pi over 3. Sometimes you might have a pi over 2, which would be nice because that would give you, actually it wouldn't be nice because it would give you an undefined. That wouldn't be good. But if you just know pi over 6 is root 3 over 2, pi over 4 is 1, and then pi over 3 is root 3, then you have less to think about later on. Okay, so now what we're going to do is we have our tangent of pi over 4 is 1, our tangent of pi over 6 is root 3 over 3. We're going to put those in our equation. So tangent of pi over 4 is 1, plus the square root of 3 over 3. And then on the bottom we have 1 minus 1 times the square root of 3 over 3. Okay. Now, for the sake of space and time, I'm going to combine a couple of steps in one. Okay, but I will explain everything as I go through. Okay. Actually, no, I'm not. I lied. We're not going to do that because it's going to be too confusing. All right. So what we need to do first is combine these fractions on the top and the bottom. Okay, we have 1 plus square root of 3 over 3. Now, we need to have a common denominator to combine those fractions. So we're going to multiply this side, the 1, by 3 over 3. That gives us a denominator of 3. So we're going to get 3 plus root 3 over 3. We're going to do the same thing on the bottom. Since it's 1 times root 3 over 3, it's the same thing. This fraction of 1 is going to be 3 over 3. So we're going to get 3 minus root 3 over 3. Okay, so take a moment to think about that. We're just combining two fractions, or two numbers together, one being a fraction. So we must make the other one a fraction by finding its common denominator. Its common denominator is 3. Okay, now, just like we did for the tangent of pi over 3 and the tangent of pi over 6, we found a complex fraction. That's what we have right here in our next step. We have a complex fraction. So we're going to multiply by the reciprocal of the bottom fraction to the top. Okay, this will cancel out all the stuff in the bottom fraction. It will also cancel out the 3's here. It will not, however, cancel out the other stuff that we have left. One has a positive, one has a negative. They are not the same, thus they cannot be canceled out. So if we rewrite what is left over, we have 3 plus root 3 and 3 minus root 3. All right, so now kind of we're in the position of where we were in the last problem where we did the conjugate. So remember, it was right here, same kind of idea, where we got the conjugate. So we're going to multiply by the conjugate again. So here's where you multiply the conjugate. So it's going to be the same term as the bottom, but you're going to change its sign. Again, this is not because of the top fraction. It is because the denominator of your fraction. Okay? It is the same two terms with a different sign. All right? So now we're going to distribute. I'm going to have to go down. Okay? So we have 3 times 3 is 9. We have 3 times square root of 3, which is 3 root 3. We have root 3 times 3, which is, again, 3 root 3. We have the square root of 3 times the square root of 3, which is the square root of 9, which is just 3. And the denominator, 3 times 3 is 9. 3 times square root of 3 is 3 square root of 3. A negative square root of 3 times 3 is negative 3 square root of 3. And negative root 3 times positive root 3 is negative square root of 9, which is negative 3, because the square root of 9 is just 3. Okay, we're going to keep going down from there. We're going to combine the like terms. On the top, we have 9 plus 3 is 12. And 3 root 3 plus 3 root 3 is 6 root 3. On the bottom, we have 9 minus 3, which is going to be 6. And the other two terms, because of the conjugate, will cancel themselves out. So we no longer have square roots in the bottom of our fraction. All right, but wait, again, there is more. Just like the last problem, we have 12, we have 6, and we have 6. They're all reducible by 6. So if you do that, you get 12 divided by 6 is 2. 6 divided by 6 is 1, with a square root of 3 left over. And this is your answer. All right, again, I do apologize. Tangents take a long time because there is a lot of work. Okay, it's not stuff necessarily that you haven't done before. Basically, what we're doing is reducing fractions, combining fractions, multiplying using distributive property. The one wrinkle in that is kind of new as far as the multiplication stuff goes is the conjugate idea. Okay, but other than that, the math is not necessarily new. It's just there's a lot of it. Okay, so what I'd like you to do next is I'd pause the video for a second and try number 3. And then come back and I'll have gone through, I'm going to do the answer next. But pause it and try doing it on your own first and then come back and see it. Okay, so take a pause. And we're back. All right, so for tangent, we're going to do actually subtraction this time. We're going to do, let's see what I'm going to do. Let's do 4 minus 3. So we have 4 pi over 12 minus 3 pi over 12. Okay, so we're going to do a subtraction one this time. It would be hard to do an addition one because, well, no, two numbers add up to be 1. That can be reduced into radians that we do know. All right, so 4 pi over 12 is going to be pi over 3. And then 3 pi over 12 is minus pi over 4. Okay, so now if you go back up to the top of the page to look at the tangent formula, now because we're looking at minus, we're going to do the green sign. So it's going to be minus on the top and plus on the bottom. Okay, so we go down to here, we're going to have tangent of pi over 3 minus tangent of pi over 4. And it's going to be 1 plus tangent of pi over 3 times tangent of pi over 4. Okay, we can kind of cheat a little bit because we've already seen both of these values. All right, the tangent of pi over 3 is, if we go to the first question, tangent of pi over 3 is just square root of 3. So we can put square root of 3. All right, the tangent of pi over 4 from the first question and the second question even is just 1. So we put these values in. So the first one we have is tangent of pi over 3 is square root of 3. All right, minus 1 over 1 plus square root of 3 times 1. Okay. So if we reduce this, or sorry, simplify it, we'll have the square root of 3 minus 1 on the top, sorry, and then 1 plus the square root of 3 on the bottom. All right. Now, again, we have a point in time where we're going to do the conjugate by multiplying the denominator by its conjugate. So it's going to be 1 minus square root of 3 on the bottom, and times 1 minus square root of 3 on the top. So this is your conjugate. All right, again, it is to get the square roots off the bottom of your fraction. All right, so now if we multiply everything out, we have the square root of 3 times 1 is the square root of 3. Square root of 3 times negative root 3 is negative root 9, which gives you negative 3. Negative 1 times 1 is negative 1. And negative 1 times the square root of, sorry, negative 1 times negative square root of 3 is positive square root of 3. On the bottom, 1 times 1 is 1. 1 times negative root 3 is negative root 3. Root 3 times 1 is positive root 3. And root 3 times negative root 3 is negative root 9, which is negative 3. Okay. If we simplify further, combine the like terms on the top, negative 3 minus 1 is going to give you negative 4. And root 3 times root 3 plus root 3 is 2 root 3's, so we're going to have 2 root 3. On the bottom, 1 minus 3 is negative 2. And negative root 3 negative root 3 plus root 3 is going to be 0. They cancel each other out, which is what they're supposed to do. Okay, and now, again, at the end, we have numbers that we can reduce. We have negative 4 divided by negative 2, which is just positive 2. 2 divided by negative 2 is negative 1, root 3. And there we go. And that is your answer for the third one. And that brings us to the end of the sum and difference of tangents.